Hello viewers, welcome back to the Multi Magics channel. Myself is Funny. Actually, Rushi is busy with developing the UI for our product, so he will be not part of this video. But I will be going through a couple of interesting things in this video. So first of all, a quick update for all the viewers and subscribers. As mentioned in the last video, our Multimagics application is available in the Play Store. So for those who did not download it, please do download, use the app. Of course, we have only very simple feature as of now, but please do review it and use it and share your feedback to us. That will be a big help to us. And as also mentioned, we our website is up and the blog is available. So let's start with a quick recap on what we did last week. So we have discussed a brief about what is a transcoding in the audio video segment. So in the video we separate the streams, and that streams will be converting into packets, and that packets will be encoded using a specific codec, and we convert that into frames, and these frames again will be encoded with a different codec, and then we convert these frames into packets, and from packets to streams, and again we put together all together in a single container. So that is what basically about a transcoding is. Okay, so in the last video we have shown you a specific piece of code how this transcoding is done. So in the transcoding, our major intention is to convert one format of the videos to other format of the video, and we have shown a quick look on how we did using the APIs available in the FFmpeg. So this is the main process conversion, setup audio, setup video, get input media stream, prepare decoder. So all these things we have discussed in the last video, but as you've seen, the more features we are adding to the product, it is tough to maintain everything in a single file. So even we are confused what piece of code is there where, and which to change, which not to change. So all this is becoming a much more headache for us to maintain. So for that purpose we have introduced a simple design to ensure we have different modules for each one. So before going into the design actually, so I would like to quickly recap a particular feature in the C++ called polymorphism. So which is called a compile time. So there are basically polymorphism is one of the C++ OOPS concepts. So we have two kinds of polymorphism. One is compile time polymorphism and the other is the runtime polymorphism. So typically function overloading and operator overloading comes under the compile time polymorphism. So poly means many, and the single function can behave in a different ways based on the arguments. For example, if you have a function to compute addition of two numbers, that the two numbers can be integer type, double type, float type. So as we can define one single function with different arguments, and you can overload that function during the compile time. And same with the operator overloading, we can define or overload the operators, and also typically during inheritance, the base class, derived class, which one to call. So those are all compile time binded. But if there is any virtual functions inside your class, then we can achieve a behavior called runtime, which means in the runtime we can call which derived class based upon the type it's derived from. So that is called runtime polymorphism, and to achieve this we will use virtual functions. And internally how this runtime polymorphism works, it is based upon the virtual fun pointers and the virtual vptr and vtable. So if you can just quickly go through any of the existing sources on the net about what is a vptr, what is a vtable, and how this runtime polymorphism works, all these things. So this is just one of the C++ concept, a beautiful concept, and we want to use it into our existing design. So now so now we will quickly look into the design once. Okay, so here is the design. So sorry, I have put the design on the paper because we are not maintaining any tools as of now, but yeah, we can quickly go through it. See, here we have interface class called MMS conversion, which is called Multimagic's media suite conversion. And then we have one derived class from this interface called multimedia suite conversion, and this is basically used for transcoding. All video and operations are done here. And then we have a separate video and audio classes which are inherited from the above base class through runtime through polymorphism, which means we can override few of the existing functions here. So this is how the design looks like. So I try to put a few UML things here, but not a complete UML. So we have, so what is this interface class? This interface class will have all the parameters. So basically you have different kinds of parameters in the interface class, like we have a input format context, output format context, input video context, output video codec context, input audio codec context, output audio codec context, input codec video, input codec audio, and again same for video and audio for outputs. And we have stream index, which is stream is our audio, what is the stream index for video, and we have the input and output files, and here we have constructors. So basically these are all the member variables of this interface class, and these are all the member functions of the interface class. I have just given the high level function names. I didn't follow any function signatures because there are quite like around 10 functions. I will show you the code. Here I'm just giving the gist of the functions which we are using. So all are pure virtual functions like init packet, init input frame, process frames, prepare decoders, prepare encoders, prepare audio encoders. Like lot of pure virtual functions are there, which means a user cannot create an instance for this particular interface class. It is just for our reference to see what are the existing things available in the in the specs. Okay, so now sorry, so now here we have one more class called, sorry I forgot to mention the class name. This class name is called MMS conversion. So here actually we have put all the video audio things here, which means like transcoding video and transcoding audio. So apart from this above parameters, we are adding three more specific parameters here, which are mainly related to the debug purpose, which are like called file pointer to maintain a raw audio file, and an actual raw audio file name, and a raw video directory. So basically whatever functions we have defined in this interface class must be override here in the derived class, or else you will be getting a compile error. So ensure all the functions you override here. You can use virtual keywords while overriding those, or you can just leave it as it is. So now from these particular base class we have designed inherited two more derived classes, called one is for video and one is for audio. So here we are overriding all the audio functions with some dummies, which means it doesn't require any functionality for the audio because only video. And here in the audio side we are disabling few video functionalities by overriding them with some dummy functionalities, like basically nothing inside that function. So but there are few virtual functions which needs to be overridden, for example process frames. So in case of audio and video, this process frame functions, we take each video frame, we take audio, we take each audio frame, and audio frame we convert into samples, and then we send it to packets, and parallelly we will be doing same for video. So here we will be processing each audio frame and each video frame, and we will be applying all the encoding and decoding techniques in this class. But when it comes to video, here actually we only do process only video frame. We don't need about the audio frame. And also here in audio class we do only process the audio frames, like resampling, FIFO creation, all other things what we have seen for MP4 to MP3 conversion. So most of them are related to audio specific, and here most of them are related to video specific. And this process frames is defined in base class as well as derived class. And during the runtime polymorphism, I mean during the runtime, based upon the pointer type, we will be calling the specific process frames function in that particular class. So I hope this is a very simple design. It's not like that we do want to follow the specific thing. We just want to start with this particular thing, so it will be easy to plug and play in the future, and it is easy to maintain the code point of view also. Okay, so I hope this design is pretty clear to everyone. And now let's see its implementation in the actual code. So now if when it comes to code part, so this is our interface class. So as I mentioned, we have all the basic member variables. I mentioned here it as protected because the derived classes wants to use this all the variables inside the functions, and these are all the virtual functions, basic virtual functions, which are common for both audio and video, like initialize the packet, initialize the frames. You should write the output file headers and tailors, and you need a function to get the streams of the input file, for example me audio and video index x. And we need to prepare video decoder, we need to prepare audio decoder, we need to prepare audio encoder, we need to prepare audio video encoder, and then these are the internal utility functions which we'll be using during transcoding audio, transcoding video, and then there's like some other virtual functions like open files. A lot of virtual functions are needed, and this is the basic constructor. So this is the spec. So now, so this is as we discussed in, so this is my basic derived class from the interface class. So I am defining a default constructor and an override constructor, or a parameterized constructor and a parameterized constructor with overloaded. So I'm here additionally passing the raw audio path and raw audio directory. This is for the debugging purpose. So, and these are all the basic functionalities. So here these functionalities I am not I'm overriding, and the derived classes can also use these functions as it is. The behavior will be the same, but these are the functions which I am defining in this specific base class. But the derived classes like audio and video can be different in those classes. These functions behave differently in those classes. Of course, few things will be matching, but few will be vary. So we'll see that. Okay, and these are the as I discussed, few additional variables required for this audio video media conversion class MMS conversion. So now if you see the implementation, so whatever we have seen, see now it is very simple and clean. So this is my basic default constructor, parameterized constructor, as well as parameterized overloaded constructor, and these are like initialize packet, initialize frames, write output file, route trailer, get stream index. So I read the input file, I allocate the context for that, and then I open the input, and then I find the stream info, and then I just iterate those streams, and then I figure out the audio stream and video stream, and I assign specific index x for it for those audio stream index. So I'm just printing for the purpose of debug. Okay, if audio stream is detected and video stream is detected if index is greater than -1. So now after that, initializations. So here is what actually we need to do. So basically, as I mentioned, these are all the process frames functionality. Here I am telling just whether it is raw audio needed, raw video needed. So all those details I am mentioning here. So like all the functions, transcode video, transcode audio, you just send the packet, you receive the frame, and in that frames you'll be having multiple packets, and you'll be encoding those packets using the encoder specs we mentioned. And in between, if this raw data is enabled, we write the audio data into the extract the raw data. So like that simple functions, encode audio, encode AV codecs, and encode video. So video is also same. You just send the packet, and then you receive all the you send the frame and you receive all the packets inside that frame. And the vice versa is the decode video behavior. So you can see that here, and this is like a prepared video encoder and video decoder, audio encoder, audio decoder. So like all the basic functionalities are explained here. Yeah, so but this is just a class. So who will create an instance for this class and how to use that in the application layer? So let's have a look. So before going to that point, we will see what is there in the video class. So in as we mentioned in the video class, here I am just overriding these audio related things using some dummies, and I am just defining again the constructor for this, and I want the function which I want to override here. So here you can see we don't need this audio related things. We can just simply put return 000. So this functionality in the runtime will be disabled. For the video, I mean audio things are not needed. Okay, so now, so this is the main function, process frames for this. So this process frames in in base class it is one behavior, and in derived class it will be having a different behavior. Of course the differences are minute, but instead of maintaining that all those if else logics inside that, we are maintaining it as a separate class, so it is easy to maintain in future if you want to change anything to video related things. So here simply we are just going through reading each frame, and then we are checking if that frame is of type video. You go ahead and transcode it, that's all. So and then once the transcoding is done, you can just clean up all the memories. So this is how video related things will be happening. But when it comes to audio, we'll be disabling the video things. Also we'll be disabling few audio things. The reason here is, here we are converting an MP4 to MP3 or a video to audio. Audio will be having a different container, and only few containers supports MP3 and other formats. So we have written a separate functionality for now if you want to purely extract audio from video, and later we'll be trying to generalize this extractor class also. So what I'm trying to say is, in MMS conversion.cpp, you have a transcode with audio. So this is one specific functionality. Here we will be not using the concept of samples. We just send the packet, we receive the frame, and then later we encode these in the encode video. Okay, but here this is like a generic audio which we generally use when you're transcoding one format or other. But if you want to extract a video from audio, we want to do much more things actually, like sampling, resampling, and then putting all the samples into FIFO, and then encoding those samples and then decoding the samples. So a lot of samples related concepts are required. So that we are all audio related things, we are capturing that in this audio class. So like resample context, and then we are also initializing the FIFOs. We are decoding the audio frame here, and then we are initializing the samples thing here, converted samples. So the samples here means, like if there is any audio in general, if there is a audio data, it's analog to digital, and then each digital value will be represented in specific bits, and specific samples will be there. So more the samples, more the audio qualities, and more the bit rate will be. Okay, so this is how audio video things are segregated. So just to quick recap, so we have a base class, we have interface class, and we have a derived class, so where all the transcoding of audio video will be done. But if you want to specifically do anything with related to video and with respect to audio, you need to use these classes. So this is how we segregated. So now we just saw the functionalities of all the, but who is the main application which is controlling all these things? So now let's go to the MM Media Suite. So if you see here, last time this MM Media Suite is of 1000 lines. So now it is just close to 150 lines. So we have separated things into modules, and we have make it much more generalized for users as well as for the debugging point of view. So process conversion, what it does, it first it starts with audio codec, and then you need to set up the video codec, and then this is the base class pointer. So based upon, so if this condition is met, which means we need only audio related things, and then we can go ahead and derive this audio type class. Okay, and we are passing the input file and output file. These are like the additional information needed when the raw data is enabled. Okay, same for video. If this audio codec is none, which means we are only doing specifically video related things, in that case we'll be using only this new MMS conversion video, and then we'll be passing this input file and output file here, and then to the construct. If you are using, if you want more data, you can just use this metadata of the raw video directory. Okay, so but if you want both audio and video, then I can simply use straight away this actual derived class, and you can pass the information of the raw audio and raw video over here. So once which class instance needs to be created, so once that is done, it is next is all rest is straightforward. So you need to pass this call this function for get the streams. Once streams are available, we can decode those streams, which is audio and video. And now comes to output part. So first we need to allocate a memory for the output file, and then we need to get few things from the inputs like frame rate, and then other things are all will be inside that function. And now we need to prepare the encoder, and we need to prepare the encoders for audio and video. So now the input format context, output format context, AV codec context, all these will be, all the data is populated until this point. All the data inside this IMMS conversion, these things are now populated with proper information once this preparation is done. So now you just simply open the output file, and you need to write actually process the frames. So now in the process of frames, if this so we generally start with empty frame and empty packet, and we initialize it, and then we just as an option, if raw is needed, we just write it into a directory. So I will show a demo on that. So now we just simply, as we discussed, like we'll just be simply processing the frames here, and then we'll be finally cleaning up the unwanted memory. So this is how the application looks like, Media Suite. All this, so these will be common for both audio specific, video specific, and audio video specific. And during runtime, which function should be called under for process frames, for other things will be determined in the runtime, because we are using the polymorphism here. So for poly means the same class here can be used to in multiple, like multiple behavior can be achieved for that particular class. So audio behavior can be achieved, video behavior can be achieved, and then both audio and video behavior can be achieved. So you can see the advantage of here. You can easily extend, you don't need to change this flow actually. So everything is controlled during the instance creation itself. Okay, so that is a major advantage of the polymorphism. Okay, so now let me quickly see how to run this. Okay, so I'm going to my build folder. So I'll just try to quickly build it. I think it is already there. And first I will try to link the libraries here. Okay, so now let's quickly look into the downloads folder once. Okay, so file explorer. Okay, so this is my downloads folder. Okay, I have this is from the previous run. So we'll be giving three options here: 1, 14 and 25. So if I give option 1, so both the actually it converts an MP4 file to MP3 file, and you should also be able to get the raw data. Okay, I think the desktop audio is disabled, but you can play it, and then this is, you will get the actual transcode data, and then you'll be getting raw video frames, and you'll be getting raw audio data. So both video audio related things are there. And if you select 25, only video related things will become like raw video and sample. Okay, so let me quickly run this. So now, so if I, yeah, ffmpeg, okay, these are all ffmpeg things. Okay, hyphen, oh yeah, okay, so I'm telling that I1 means here the it do conversion, and this is conversion on which file, on this specific input file. And if I know 25 means I am telling convert this MP4, only extract video from this specific file. So now let's see what is happening now. You see here, very good, interesting. So here the video stream is detected, and this is the video decoder, and this is the video stream details, and I'm converting this H264 to H265 now, and it is each frame we are processing, and we are ignoring the video packets and other things, and we are only focused on the video packets. So input file is read, all the contexts have been filled properly, both the input audio, input video, output video. But in the actual runtime, we do only use the video packets thing, and context, audio context also will be empty in this case. Sorry, I just said I will be populating all the things, but since this is just a video thing, we'll be only populating the video related things here. So now let us see what is happening. I think it is almost done, so let's just wait for a couple of seconds and then we will see what is happening. So let us quickly see what is happening. There you go, you can already see here. Yeah, so raw video directory is created. So this is for debugging purposes. We have enabled this raw video just to ensure reading. So you can see here each video is just image. The number of frames is image. So this is our sample MP4 file, and then yeah, you can see here these are all the images here. So yeah, so if you can play it in a real quick player, 20 frames, 30 frames, you will be getting a motion as if the images are moving. So a total of let me check, I think the process is done here. You can see all the frames are completed encoding. Around 1252 frames are encoded. That is just a rough number, so we'll see actually how many frames are encoded. Okay, yeah, it's close to same the number. So here we have extracted the raw video from the actual sample.mp4, and also we have transcoded the existing H264 video codec into H265 video codec, and then the container is still the same, and audio is from AS to AAC. So we are not changing much on audio side because this is only video related things. You can see here it is playing now. Okay, but there will be no audio. This is just video, simply because we just extracted the video from the MP4 file. So this is one use case. Okay, so now let's see what will happen if I just choose one MP4 to MP3. One means, so now the expectation is MP3 file should be generated, and audio file, raw audio file also should be generated from the input. Okay, so yeah, done. You can see here MP3 file is generated, and also raw audio file is also generated. So typically this raw audio file you can play through Audacity actually, and this will be very helpful through debugging. Once the Audacity is launched, you can just simply quickly go here, and then you can go to import, and then you can import audio. Sorry, we need to import the raw data. Import raw data, and then you can select from the downloads. This is the current raw audio. You can click open, and then we need to import these things. These are the basic defaults which are used by the Audacity, and if you click on this, you can hear the audio. Okay, so I am able to hear, but since the desktop audio is disabled in the recording, the viewers might not be able to listen. But yeah, I just checked, these are all the samples. So these are, as we discussed, these are all the samples actually. You can see here, yes, these are all the raw samples. Okay, so now one last thing we will do is we'll do the actual transcoding. Okay, both video and audio are converted. No, not just, we are not extract previously we just extracted video, now we extracted audio. Now we are like transcoding both video and audio to different formats. For simplicity, I am just transcoding audio from AAC to AAC, but for video we are transcoding from H264 to H265. Okay, so this we already seen in the last week, but I am giving, so see here in the earlier option we are just ignoring the audio frames, but here we are transcoding both audio frame and video frame. So it means like the input file is opened, all the contexts are allocated for both audio and video, and now we are processing the each frame. So these frames are the packets are converted into frames, and these frames are we are like transcoding. Transcoding means first video decode and then encode. Okay, so the process it will take close to 50 seconds for the entire conversion. So yeah, let's wait for a couple of seconds and then we'll see what is the output. Okay, so we'll quickly wait here. Yeah, I think since we are doing transcoding, three kind of things will be generated here. Will be generated a raw video. By default, raw video and raw video is out is enabled, and also will be generating the MP4 file. So this is, if you go to raw video, as we have seen earlier, all these videos, all these frames are coming up. The process is still growing, and close to 800 frames are done. So we'll see. We will wait for 10 more seconds to ensure all the frames are encoded properly. Now it's almost done. So this is the raw audio. Once this audio file is all set, it will be showing in this format. So these two are created using the option 25, which is extracting video, and also by default you are enabling the raw video. So these two are created as a part of option 2, which is 1 MP4 to MP3, where MP3 is generated as well as the raw audio is also generated. These are the things generated using option 14, which means a video file is generated which is transcoded with different encoders for audio and video, and this is the sample audio. I mean, this is the raw data and this is the raw video. Okay, so looks like the process of the transcoding both video and audio is completed here. So now we can quickly, yeah, it's completed, and then we can just quickly play and check. But yeah, I already checked it is working. Yeah, so no need to recheck those again. So this is how the architecture looks like, and with the help of this architecture, how smoothly we can maintain the code, we can understand the code, we can see, we can plug and play with the different features. And this is like kind of more of our approach, but we are open to change this design a little bit up and down based upon the kind of challenges we face, adding the more features to the product. So we are open to that change also. So on that note, I would like to stop this session at this point. So I just want to convey to all the subscribers and viewers about this re-architecture of the existing video code. I mean the conversion with the help of the polymorphism concept and how we use it in the real-time application here. I hope I am clear for all the viewers and subscribers. So the next video will be very interesting. So for now, all the days we are talking about video and audio, and conversions, but what we can do with the existing FFmpeg commands. Few viewers are asking, can you please explain us how to use the basic FFmpeg commands? So I will be going through this in the next video. So for now, thanks a lot for all the viewers and subscribers who have been watching us and keep encouraging us so far in our journey. Have a good day. Bye bye. Take care.